Hello everyone, I'm John from Vulgar Kitten Studios and welcome to episode 5 in our How to Make a Video Game series. And in this episode what we're going to be doing is setting up an AI system for our tanks to move around. And Unity does actually come on board with a free pathfinding system, however you have to have the pro version of Unity in order to use it. So what we'll do is we'll use a third-party resource called the A-Star Pathfinding Project. So go on over to aarongranberg.com/astar and download this package. There is both a free and a pro version. The pro version does give you a few little extra features like automatic nav mesh creation. However, we're not even going to be using nav meshes for this one. We're going to be using a dynamic grid. So go ahead and download that and you'll get a zip file with a package, or a Unity package. And I've already downloaded mine, so I'm just going to grab my package here and we'll double click that to import it into Unity. And go ahead and import. And it's going to take its sweet time. Compiling scripts. Compiling. This little video game engine that could right here. Chug-a-lug-a-lugging along. Alright. Yeah, we got that in there now. And in order to use this, the very first thing that we need to do is go ahead and create a new empty game object. And I'm going to rename this to A-Star. And I'm actually going to drag it onto my level 1 and reset its position just so that's where it starts by default. And I'm going to go ahead and give it a red label. And on this, I will go into Add Component, go to Pathfinding, and add a Pathfinder. And the Pathfinder will give us all these new wonderful, glorious options. And usually it will ask you if you want to enable JavaScript or not, but I've used it before, so I don't think it's really going to think that I'm ever going to use JavaScript, because I'm not. But if you are going to use JavaScript, then you should see a button that asks you whether you want to use JavaScript or not, and in order to use it you do have to enable JavaScript support or else it will not work. That being said, let's go ahead and create a grid graph. So we've created a grid graph and we can see immediately that it's scanned our level and it's set up a path. And the way that pathfinding works is it calculates the distance between 2 points and gets the fastest route. And the way it gets these routes is using these little bitty vertices in this grid that we can barely see on the screen here. So each vertex in this grid is a waypoint in our pathfinder. And because it's so small, we are going to need to make this a little bit bigger. And since we've already got our pathfinder where we need it, first thing that I'm going to do before I do that is just grab our A-star object and move that up here, because I like it to be in the center above the level, I suppose. A little bit just like a light hanging there. Okay, enough chit chat. I'm going to go ahead and grab our graph, and we're going to decrease the node size by 1/2 and the aspect ratio by 1/2. And I'm going to increase the width to 31 and the depth to 20 so that I can cover my entire level. Alright, and also we are going to need some obstacles for our AIs to navigate around, so I'm just going to grab one of these blocks over here and duplicate it and bring it over. And that should be gray in my inspector instead of blue because I got a prefab. So I'm just going to actually create another empty game object right here. Grab that sucker, pull it into level 1, and call that obstacles, because I like to keep everything in their own neat little hierarchies. Put that cube on there, and we do need to add some box colliders to them for them to work with the nav mesh agent. So we got that on there now. And one more thing that we're going to need to do is we're going to actually need to add this tag obstacle. So it's already tagged obstacle, and the way that our rays work, they also work in the same way as our little ricochet system. They just fire a bunch of rays and they calculate the paths whether or not they intersect a layer mask or array on an object with the same layer mask. There we go, I said it right. Okay, so I'm gonna put this probably somewhere like right here. I'm gonna duplicate it and bring it out. Just place them randomly throughout the level, probably over here somewhere, and duplicate it again, bring it down here, and maybe rotate it a little bit, about like that, like that. Okay, and so we're not actually getting any non-traversable points, so we need to set up our pathfinding system to be able to calculate where we cannot go. So let's go ahead and click on A star and go into collision testing and click obstacle for our capsule, or for our collision testing, and that'll be the layer mask that it cannot go through. So we'll click scan, and now we can see we got all these red markers, and that's where it's going to navigate around. Now you can also see that some of these objects don't have squares lining the entirety of their sides, and this one could probably actually come over a little bit, so I'm going to go ahead and grab our obstacles and grab this guy, move him over here, grab A star, and just rescan to get it right there. And the reason that we don't, and like this right here, because we have traversable terrain near objects, it can cause problems and AIs will start running into walls, and we don't want that. So we'll go into our collision testing again and increase our diameter by 2. And we'll also need to rescan, and when we do that, now we can see all of our objects are actually completely encompassed in non-traversable terrain. Okay, so now that we have that, let's go ahead and get an enemy in here. So let's grab our enemy prefab. Well, first I'm going to come over here, put our enemy prefab in here somewhere, and go into perspective, get up to him, and put him on the floor, and get him out of the object, and go back into orthographic, look at him from the side, and we're going to give him a character controller as well. So physics, character controller, set the height to 0, set the y to 1 or 0.25, and 0 to negative 0.1. Okay, so we got that now. We need to set them up essentially just like we did ourselves. So we go into the turret, and we can see we already have a muzzle right there. So cool, and yep, so that's pretty much it. And we'll also need to go ahead and just start making some AI. And we won't move him around at first. Let's just get him looking at us. So we'll go into our scripts folder and drag our smooth look at script onto the turret. And we're going to need to make some edits to the script, so I'll go ahead and double click it to open up in MonoDevelop, and turn it on here, smooth look at, and get rid of all these, and we'll need to go ahead and create one of our own variables and call that bool set, and we actually want to initialize it to be true, and put 2 semicolons, don't do that. And in update, we're just going to say if our target is equal to null and our set variable is equal to true, then we want to say target is equal to GameObject.find GameObject with tag, and the tag that we want to find is player. And since our transform variable is a type transform, we have to get the transform extension off of that, and finally set the set variable to be equal to false. And finally, we'll make this an else if statement, so else if our target does exist, then we'll go ahead and continue on with the script. Otherwise, we need to find a target first. So that way we'll always ensure that we have a target and we don't have to just drag it in the inspector. It's kind of dumb doing it that way. Alright, so we'll get this on here, and once it compiles, we need to make sure we take our player and tag this guy as player. Eventually we will be using an enemy tag, so I'm going to go ahead and add the tag enemy. It looks like we already have the tag mine may have included that in our builds, and we will be using that tag as well. I don't know if we'll be using wall or projectile. Anyway, that's there if you need them. And in our prefabs, mine is tagged mine. Okay, cool. Well, let's just go ahead and start up the game, see if he looks at us. And he is looking dead at us. Alright, this is exactly what we want. Looking good so far. So, now let's make him move. And fortunately for us, there's actually been a very good script written for A-Star Pathfinding, for the A-Star Pathfinding project. It's not meant for high performance, but our game is small enough to not really need a high performance script. So we'll use that script, and I'll go into our enemy, and I'll add component, go into pathfinding, and look for AI, and we'll add the AI path generic. And we're actually going to edit this script as well. And before we do that, I'm going to go ahead and explain how our AI system is going to work. Essentially what we're going to do is we're going to position some objects throughout our terrain that our tank is going to randomly pick one of those objects and try to get to that point, and then wait there for just a split second and then move on to another random point. And that's how we're going to create our AI. So the way that we're going to do that is, first of all, I'm going to create a new game object and drag it onto our level and zero it out, drag it back off, and call it nodes. Then I'll create an empty child and call this one node underscore 1, and we'll go ahead and get this a gray tag so we can view it. And I'm going to go ahead and place this, well, I need to make sure I get off of there, place this somewhere over here. Let me turn on A-Star so I can see where our paths are, and put this somewhere over here. And actually that looks like it may be a little bit too far over, so I'm going to grab this object here in our obstacles and move this over and just rescan our level so we can get a better navigation off of that. Probably, well, yeah, that looks about right. That looks good. We got paths everywhere. Okay, so we'll go ahead and grab our node and duplicate that guy. I'll bring him up here somewhere. And node 2. Three. Duplicate it. 4. Duplicate this guy again. 5. Duplicate and call him 6 and put him somewhere in the center. Okay, so now we got a bunch of nodes through our level so our AIs can function appropriately. Okay, so now we'll go into our script here and we'll hit Control F and find the awake function. So here it is. Well, that's the seeker. We don't want the seeker. We want, let's see. Well, we do have the seeker. We require the seeker, but we want the A-Star or AI path. That's the one that we want to edit. So we'll find the awake function in this one, and here it is. And we'll add in our own variables. We'll put in our public and make an array of transforms called nodes, and we'll make a couple of floats. Float rest time, so the amount of time that the object will stay at a certain point before it moves on to the next. Max distance, which is the amount or the distance away from an object before it starts its logic to start its waiting process. We'll need an enumeration called state, and we'll make one called moving and one called waiting. which is actually going to be an empty state, so we can just wait and then start moving again. And so we'll make another state, or we'll make a reference to our state enumeration and call it state equal to state dot moving. And then in our wake function, we'll go ahead and set up our target. So we'll say target is equal to nodes random dot range, and from 0 to nodes dot length, and that's going to be our target. Now let's just go ahead and go all the way down to the bottom of the script, and we're going to create an enumerator for our wait, and we'll call that rest. And in here we'll first set the state to state.waiting, then yield return wait for seconds and rest time, and target is going to equal the nodes random dot range again from 0 to nodes dot length. And then finally, we'll set our state back to state.moving. And now we'll need to find our update method. So update, and we'll just make some space for ourselves and start constructing a switch statement. So we'll switch on our state variable and set up our cases. So case state waiting, yeah, fine, which is going to be empty, and then our case state.moving, which is where we're going to have our movement logic, or not our movement logic, but our controller logic. So we'll say if vector 3 dot distance, and we'll check the distance between our own position and our target position, and check if that is less than our max distance. And if so, then we're going to start our coroutine rest. And save that off. And looks like we got an issue here just because I never put the colon on waiting. So we'll save that off and go back into Unity. Let this compile. And looks like we have an error, so let's see where it's at. And that's because we didn't use the new directive. And we're compiled now, and now we can see that we have this new array that popped up called nodes. And just for more difficulty and more agents, what I'm going to do is I'm actually going to grab another prefab. I'm going to first of all take our enemy and apply his changes, and go into prefabs and grab another enemy, or matter of fact, instead of position him again, I'll just take this guy and duplicate him and move him over here. So that way we got two enemies. And enemy 1 is going to get nodes 1 through 3. So I'll say 1, 2, 3. And enemy 2 is going to get 4 through 6. And our speed is going to start out at about a 3. I actually want to drop that down to maybe a 2. And maybe 1.5. And let's start the game. And these guys don't want to move. So again, to save on time, I'm going to pause the video and see what's going on, and I'll get right back here. Okay, The issue was, and I always forget this, we're not doing any kind of vertical movement at all. So what we're going to need to do is actually reset our uh, climbing and slope variables in our A star. So select your A star object and come down into the grid graph, and notice here it says that 0 indicates that you want it to be infinity. So what I do is just set them to 0.01. So I set the max climb to 0.01 and max slope to 0.01, and it starts working. However, there can be occasions where they will run into each other, run into other objects, and they'll appear to like float over them. And it is a great idea to go ahead and reset your slope and step offset limitations in your character controller. So I'll go ahead and set those to 0 and click apply and grab our enemy, make sure that that happened. Okay, so now when I click play, they are going to be navigating between each other's AI points, or their AI points. So, and we can still collide with them and everything. So everything is working as it should be working. And now we'll just get them firing at us. And the way we're going to do that is we're going to actually create our own script. So we'll go into our scripts folder and right click on that, create C# script, call that turret, and go ahead and open it up in MonoDevelop. And we'll say, well, we won't do that. We'll come into our class, make a public reference to our bullet, and a public float for our fire rate. And we'll need a boolean to decide whether we can fire or not. We'll need a transform for our muzzle, and we'll need a reference to our smooth look at component. So we'll say look at, and float for hit check range. Because we don't want bullets flying all over the place all the time, we're going to put in some kind of functionality so we can check to make sure that there's nothing in the way of us, of our enemy and the player, so that they can fire. And we'll go ahead and take our start method. First thing that we'll do is set our, well, first we'll set our muzzle to be equal to transform dot find child, and the child that we're going to find is muzzle, and look at is equal to get component, and smooth look at, and we'll set fire to be equal to true. And now we'll go and make an I numerator for our firing. So now we'll just call this fire and yield return wait for seconds. And I use this method a lot if you haven't noticed. And we want to wait for the fire rate to happen. And transform.instantiate our bullet at our muzzle dot position and our muzzle dot rotation. Finally, we'll set fire to be equal to true so we can fire again. Okay, and in our update method, we'll first check to see if we have anything to fire at. So we'll say look at the target is not equal to null, and if that's the case, we will set our hit check range to be equal to vector3 dot distance from the muzzle dot position to the look at dot target dot rotation. Rotation? No, position. And then we'll go ahead and perform our raycasting, and we'll use physics.linecast for this one. And first we'll say, we'll actually want to say if not physics.linecast, and then the muzzle dot position, and then the end will be a new vector 3, which will be muzzle dot position dot position dot x muzzle dot position muzzle dot position dot y, comply here, muzzle dot position dot z plus 0.05, just some kind of bunk dampening value that we can push in. Or actually, no, we already set up a hit check range, so we actually need to add that in there too. So we'll say that we'll increase that to 0.5, and we'll check our hit check range. And finally, we'll need to add a layer mask, which we need to actually make that a public inspector variable. So underneath here we'll say public layer mask is equal to layer mask. And the reason that we do this is because we don't want to intersect, or we don't want objects with the layer obstacle to allow us to fire. Okay, so now we'll say if our fire variable is true and look at dot target does not equal null, then we'll start coroutine fire, and we'll set fire to be equal to false. And let's go ahead and go back into Unity and let this compile. We have an error here, and I forgot again to put the new directive, so put that in there. Okay, so let's check our enemy turret, and now we'll want to put our turret script on there, and our fire rate we'll probably want to set to something like 0.7, and we'll go ahead and apply. And also we'll want to add in the prefab that it needs to instantiate, which is going to be enemy bullet, and again apply. So we'll start, and now it can fire at us. Is the breakcasting working? We're moving quite a bit faster than I'd hoped. Let's actually spread these obstacles out just a little bit, just to give us more room to work with. I want to put that right there. Put that more down here. I'll grab A star, and it's already recalculated, but I might want to change the diameter to 1.5 and rescan. Okay, that looks good. And okay, our raycasting isn't working because I did actually forget to do something. I need to go into our enemy and go into our turret and put on our layer mask obstacle. So we'll start the game. And we can see that they're delaying here. They don't want to fire at us. Oh, not quite. That's because I actually need to take my self and drop my step offset and limit off as well. Okay, so maybe we should take that bunk value off of there. Let's just do it like this. Use the hit check range and let that compile. Raycasting is just not agreeing with us right now. Okay. So we may want to go ahead and say something like else return. And let's just go into our scene view and see if we can see what's going on. Well, I know one thing's for sure. I actually want to stop the enemy from firing so much. I'll drop that down to 1. We do have obstacle. That's an obstacle. Okay, this one isn't firing, so our raycasting is actually working. We just have some collider issues. Alright, so we know at least our code's working, and this video is getting kind of long, so I think that this is actually going to do it for our system, and I hope you enjoyed it. We'll see you in the next one. Thank you.